Everyone thinks planets need a star. They don't. For centuries, our cosmic understanding has been tethered to the sun. Planets, by definition, orbit a star. This fundamental assumption, deeply ingrained in astronomy, shaped how we searched for other worlds and how we defined their very existence. But the universe, as it often does, holds surprises that challenge our neat categories. Beyond the familiar dance of stars and their retinues, an entirely different class of celestial body roams the void. Planets untethered, adrift in the frigid, silent expanse between star systems. These are the rogue planets, also known as free-floating planets or even nomad planets. They're worlds that have been ejected from their birth systems or perhaps even formed independently, never knowing the warmth of a parent star. The idea of such worlds isn't new. Theorists have pondered their existence for decades, but it's only in the last 20 years that our observational capabilities have advanced enough to actually detect these elusive wanderers. Their discovery opens up a profound shift in how we perceive planetary formation and evolution, suggesting that the galaxy might be teeming with far more planets than we ever imagined, many of them lost to the deep dark. So how exactly does a planet become a rogue? One primary mechanism is gravitational ejection. Imagine a young planetary system still in its chaotic formation phase, with multiple gas giants jostling for position. A close encounter between two massive planets could hurl one of them out of the system entirely, like a cosmic slingshot. This isn't a gentle push, it's a violent expulsion, condemning the planet to a lonely journey through interstellar space. Another possibility, though less common, is that some rogue planets might form directly from collapsing gas clouds in interstellar space, never having been part of a star system to begin with. These are not just theoretical constructs. In 2011, astronomers using microlensing techniques identified the first definitive evidence of free-floating planets. Microlensing relies on Einstein's theory of general relativity. When a massive object, like a rogue planet, passes directly between an observer on Earth and a more distant background star, its gravity acts like a lens, temporarily magnifying the light from that star. The duration and intensity of this magnification tell us about the mass of the lensing object. A short, sharp burst of light suggests a planetary mass object. This method is incredibly sensitive, able to detect objects down to the mass of Earth. One notable discovery involved an object designated Argyle 2016 BLG 1190 LB. This was a super-Jupiter, about 13 times the mass of Jupiter, and it appeared to be drifting alone. Its massive size made it easier to spot. More recently, in 2020, an international team announced the detection of what might be the smallest rogue planet yet, Argyle 2016 BLG 1928, with a mass comparable to Earth. This discovery, made with the Polish Argyle project at the Las Campanas Observatory in Chile, was a crucial step. Finding such a small object suggests that smaller, Earth-sized rogue planets might be far more common than we initially thought. The implications are staggering. Some estimates suggest there could be hundreds of billions, even trillions, of rogue planets in our Milky Way galaxy alone. That's potentially more planets than stars. Imagine this, a planet, perhaps rocky like Earth, drifting through the ultimate cosmic wilderness. No sunrise, no sunset, only the faint, diffuse glow of distant galaxies and the occasional twinkle of a far-off star. The surface temperature would be brutally cold, just a few degrees above absolute zero. Any atmosphere, if it existed, would likely be frozen solid or stripped away by cosmic rays. Life, as we know it, seems impossible under such conditions. But what if these planets harbored internal heat sources? Geothermal activity, for instance, could create subsurface oceans of liquid water insulated by thick ice. Worlds like Europa or Enceladus, moons in our own solar system, offer a tantalizing parallel. They possess vast subsurface oceans, heated by tidal forces, despite being far from the sun. Could life, perhaps even complex life, evolve in such an environment on a rogue planet? It's a speculative but compelling thought. These ocean worlds would be self-contained biospheres, completely independent of stellar energy. Detecting these internal heat sources or any signs of life would be incredibly difficult. Their isolation and the vast distances involved make direct observation nearly impossible with current technology. The upcoming Nancy Grace Roman Space Telescope, with its wide-field infrared vision, is expected to greatly improve our ability to detect more of these rogue planets using microlensing. Each new detection refines our understanding. Rogue planets force us to rethink the very definition of a habitable zone. Perhaps life isn't confined to the narrow band around a star, but can thrive in the dark, sustained by internal forces, making the universe even richer with possibilities. These are not just cosmic oddities. They are a testament to the sheer dynamism of the universe and a profound reminder that our understanding of existence is always expanding, always challenging our preconceptions. Journey with us next time as we explore the hidden history of the first interstellar visitor to our solar system.